this works. Yes, it's working.
It worked,
Okay.
Gary. That's crazy.
All right. So
Wait, are we starting the video?
we've already started the video.
Why?
So we are going to do, sorry,
We didn't do it
it's because you guys weren't focusing. Okay, lights.
Camera, fraction.
Yeah.
Stuffy, stuffy,
That was
stuffy.
We're really
beautiful.
together.
That was amazing.
All right, so we're going to talk about exponent rules. I normally teach this a little bit later, but I realize when I teach it sometimes, there's a lot of rules in exponent rules. And in the beginning, they seem really simple. But as you move into harder stuff, they can seem very complicated. So my sense was I'm going to try it this year where I'm teaching a couple rules right up front. And then we'll have a chance to practice them over a few weeks. And then I'll start moving into harder rules, okay? And see if that gels better. I've noticed when I give too many rules, everybody, their brains turn to mush, okay? So basically, think about algebra. What is algebra? Algebra is a shortcut. It's basically a series of shortcuts to math. A lot of algebra is about creating shortcuts. And exponent rules is that very thing. It's actually creating rules that make it shorter so that you don't have to do it the long way. Now, first of all, let's just be sure we understand what an exponent is. If I said 4 squared, what is that?
4 times 4.
Yes, so that squared says it's, this is, first of all, let's talk about base and exponent, power. This is the base, 4 is the base, in this case, and that is the power or the exponent. The 2 is the exponent or the power. This is the exponent, or you could call it exponent or power, right? You could say 4 to the power of 2, or you could say 4 to the second power, or you could say 4 squared. You could actually say that for squared and for 2 and 3. You could like this could be, you could say that's 4 squared. This you could say 4 cubed, because 3 is the same as a cube, right? 3. And so, but as soon as you get it higher than that, you're going to have to say 4 to the 4th power, or 4 to the 5th power, or 4 to the 6th power, or 4 to the power of 6. Or you see what I'm saying? Yes.
So, can you just tell me something about 4 squared is in the second dimension and 4 cubed is in the third dimension. What is 4 to the fourth dimension? There is a fourth dimension. There's like an infinite amount of dimensions.
Yes, and when you figure that out completely, let me know. Okay? That's a great question. But you're totally right. When we're talking about squares, we're talking about this. 4 squared, if this side is 4 and this side is 4, what's my area?
16.
Remember, it's base times height, right? To have a square, base times height, so it's 16, right? 4 squared is 16. Now, if I made this a cube, right? Then, and this was 4 as well, then my volume, not my area, volume is cubed, right? Would be 4 times 4 times 4, which is, I think, 64, right? So what this means is 4 times 4. What this means is 4 times 4 times 4. What this means is 4 times 4 times 4 times 4. Okay? What does this mean? X to the 5th.
The 5th dimension.
It means x times x times x times x times x.
Yuri, what is d squared?
B squared?
D.
D squared?
D.
D. Right.
Nice, dude.
All right. Now where was I going now? I lost my train of thought here. No, that was good. That was good. But I just forgot where I was going. I had a great idea. Okay. Oh, I know what I was going to say. Now, what is this?
Wait, why are there X? Oh, no, there's X's now.
What would this be, guys? I'm just curious. X plus X plus X plus X plus X.
That'd
it just be 5x's?
It would be 5x, right? That is not exponents, right? You're not, I mean, there are exponents to this, but you're only adding, and as long as they're all the same exponent, they're like terms. So Bella and Skylar, just try not to talk, okay? If you can, during this. So when I add all these x's, I've got 5x's. But when I'm multiplying, it's x to the 5th power. Guys, you all understand this, right? It's pretty straightforward. Okay, so now what we're going to talk about is the very first rule. But actually, before I write the rule, the shortcut rule, we're going to do it the long way. If I said x to the 4th times x to the 5th. All right? So,
Would it just
yes,
be
that
4x?
is correct.
No, it'd be 9.
But basically, what is this? This is x times x times x times x, right? Yes? And hang on one second. Different color. And this one is x times x times x times x times x, right? So what's my final answer? X to the 1, 2, 3, 4, 5, 6, 7, 8, 9. It's x to the 9. So I know my answer is x to the 9. So if you look up here, though, what is the shortcut you notice? You can, when you're multiplying same bases, the bases have to be the same. They're both x's, right? Right? Right, John? They're both the same bases, right? You add the exponents.
So when you multiply the same bases, you add the exponent?
Yeah, exactly. So here's the rule. Here's the way I would write rule number 1. Rule number 1. A to the m times a to the n is equal to the a to the m plus n.
What?
Gary, this makes absolute sense, Gary. I see where you're going with this.
Okay?
Yeah, this is totally.
I switched the base. Instead of saying x, I did a just because I wanted to make sure you get the rule. That
totally
the base is a. I'm multiplying the bases. That they both have their own exponents. This one has the exponent of m. This has the exponent of n. If I'm multiplying same bases with exponents, I write the base, and then I add the exponents, m plus n, right? So let's try that rule. That is such a great rule because if you don't know that rule, it will be really hard when you get to something like this, x to the 24th times x to the 42. You would be writing a lot of x's, right? So thank God for algebra. Thank God we've come up with shortcuts.
Then couldn't you
Right?
just do x to the 66?
So using my rule, right? I have same basis, so write in your notes, John. Should we write, do you have this written down as your title?
Exponent 24.
So it's going to be, so I have, my base is what? What's my base?
X.
X. So I'm going to write my base, and then I'm just going to add 24 plus 42, so that's 66. Is that right?
66.
I'm done. That's pretty easy, right?
Oh my
That make
God.
sense? Let's try another one. How about x to the 8th times x to the negative 3?
X to the negative 24th, right? It'd be x to the negative.
No, it'd be x to the 5th.
Yeah, it'd be x to the 5th.
All right,
X
Amaya.
to the 21.
Amaya, what do you do when you multiply same
Oh,
bases?
never mind.
You add the exponents. You don't multiply. That's the common mistake. A lot of people will multiply the exponents. Do not multiply the exponents. Okay? Okay? So it will be x to the 8 plus negative 3, or 8 minus 3, which is equal to x to the 5th. So make sure you're writing these down, all these problems, so that you can see what we're doing. And write that rule, so you're used to that, because you'll see that again and again. How about I gave you this? X to the 10 times x to the negative 20.
X to the negative 10.
X to the negative 10.
Oh my God.
Eventually, we're going to talk about another rule that says you can't leave your answer like that. But we're not going to get there yet.
Oh, I know how to do that. You divide.
There's a lot of rules that you don't. None of you have learned all these rules.
I know one of them.
You know, you've learned a
Other
bunch.
than the one that I think
What?
brain.
Yeah, say it again. Oh, your brain poofed, exploded. All right. So now I'm going to make it slightly harder. What if I gave you this? 2x to the 4th times x to the 5th. What would the answer be?
Wouldn't you have to divide?
By 2.
But-
2x to the 20th?
It's
2x
2x
to the 9. No.
Say.
9.
2x to the 7. No,
Do we do, because you do x to the 10th?
What?
X to the 7th, yeah.
So do you guys know the commutative property? I think we've
X
talked
to the
about that.
4.5th.
What does the commutative property say? We'll just say, what does the commutative property say?
Isn't it whatever you do to one side, you can do to the other?
Commutative, like, commute means to move from one place to another, right? So basically, the commutative property says this: A times B is equal to B times A. So 2 times 4 is the same as 4 times 2. 8 is equal to 8, right? So it's okay with multiplication to swap numbers around, right? So I could say, what is the number hidden here?
1,
A 1. 2 times 1 is
2.
2. X to the 4th times x to the 5th is x to the 9th. So that's pretty easy, right? That one was pretty easy.
It's like divide the 2 into the 4, and then so that's.
Right, so what I did in my brain is I did 2 times 1 times x to the 4th times x to the 5th.
Then couldn't you do
What if
x
I gave you this?
to the 4.5th?
What if I gave you this?
No, 'cause you're
3x
adding the
squared times
Well, yeah, but if you divide
4x to the 8th.
Wait, but Gary, wouldn't you have to simplify it to get an x? Then wouldn't you do x is x to the 4.5th?
So this is 2x to the 9th.
So then wouldn't you simplify it?
4 plus 5 is 9.
I know, but wouldn't you simplify it and get x to the 4.5th?
Well, you can't do that because you don't
No,
have an equal
this
sign.
doesn't have anything to do with the exponent.
Because you need an equal
Yeah.
sign to simplify.
So, okay, whatever. So how about this one? I'm going to now, in my brain, I'm going to think of this problem. 3 times 4 times x squared times x to the 8th. That's what I'm going to be doing. So 3 times 4. 3 times 4 is 12. Okay, x to the x squared times x to the 8th. X squared times x to the 8th is x to the 2 plus 8 x to the 10. You got it? Okay, does this make sense? What if I gave you 6x to the 6 times 4x to the 11th? What would it be? 6 times 4 is 24
Yeah.
4x to the 17.
x to the 17. 6 plus 11 is 17. Fist of 5, you guys get this? Is it making sense to you?
Okay.
I think, let me just see. Let's just do one more, couple more, just to be safe. Whoops. How about this? How about, I'll try this. 1/2 x to the 4th times 8x to the 12th. Negative 12.
Gary, you're confusing us.
Wait,
Oh, wait.
so it would be 4, wouldn't it be, so it would be
What is
4x
1/2
to
times
the
8?
8th? It
What's
would be
half
4x
of
to the
8?
8th.
4. 4.
It's 4x to the 8th.
X to the
Wait, no.
4 minus 12. What would that
4x to the 8th.
Four solve is
So negative
negative
8.
Negative 8.
No,
be? Negative 8. And eventually you're going to learn how to go one step further in that. We're not going to go there yet. That's another rule. Does that make sense? Did I lose you?
Wait, is it the negative?
So half of 8 is 4.
Okay.
Yep. You got that? Okay, how about this one? How about negative 2x to the 5th times negative 3x to the 6th?
Negative 2 times negative 3 is positive 6.
Negative 2 times negative 3 is positive 6.
It's
To the
6.
6x to the 11.
X to the 11. Good job. Excellent. Good job. That's the first rule. You're just understanding. You have to, now, what if you saw something without x's? What if I gave you this? 5 to the 3rd power times 5 to the 8th power.
What?
10 to the
Oh, then it'd be,
11?
no, then it'd be 5
25
to
to
the,
5 to the 11.
No,
yeah, 5
it's
to the 11.
no,
to the 11.
it's 10 to the 11.
No, 5 to the 11.
What is the base?
25.
I hear different
5.
answers, and some of you are
The
right, some
base
of you are
is
wrong.
5.
The base is 5. What was the base here?
X.
I mean, the base is, well, I guess that's not a good example. In this, what's the base? A. What did I do to the x? So I wrote the A in the answer. The base is in the answer. So 5 to the 3rd times 5 to the 8th. 5 is my base. So I have to write 5 as my answer.
But
And then 3 plus 8 is 11, right?
And then it'd be 11
That's
times,
as far as well,
And
I
then
can
it'd be
go 5
5
times 5 times 5. Now I do not, when I give you these, guys listen about this, okay? When I give you a problem like this, I'm not expecting you to tell me what 5 to the 11th is. Don't go 5 times 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 5, right? Don't do that,
Isn't there a calculator set up?
right?
Like, to the
Your calculator can, some calculators can figure that out real quickly, but some can't. Some, you have to just keep hitting 5 times
5 times 5.
11,
equals, I don't know, something like that. All right, what about this one? 10 to the 9th times 10 to the 10th.
19. 10 to the 19.
10 to the 19th. Good job.
And then it'll be
Right? It's not 100 to the 19th. It's 10 to the 19th.
because 10 times
Okay.
10 is totally not 100.
Yeah. Okay? These are unbelievably useful in science. When you're trying to figure out the distance from here to another planet, or the distance between 2 different stars. You know, you're talking about huge, huge numbers. And so people use scientific notation. You guys remember those? Scientific notation? Like 2.3 times 10 to the 4th power. Things like that. And you'll find, eventually we'll do some problems, you'll see how these rules apply to scientific notation and make it far, far easier. Skylar and Bella, can you sit down and stop, please? Can you move that way, please? I'm gonna map it with you guys. You move that way? Thank you. All right, so that's it.